In October of 2010, a delegation from Maine visited its sister state of Aomori Prefecture in Japan. Among other stops, the delegates visited Mutsukaden Toki Company, which manufactures specialized equipment for the scallop aquaculture industry and specifically a technique called ear hanging. Following are brief clips of the machinery that the delegation observed and descriptions of their functions. The video is courtesy of Dr. Christopher Davis of the Maine Aquaculture Innovation Center.
So you can actually see where kind of loud.
The Japanese scallop is Patinopecten yezoensis, or the yezo scallop. One of the first steps in the process is to grade the shells to approximately the same size. This is done so that the holes can be properly placed near the hinge of the scallop, shown in the next step. This machine produces 3 size categories or grades.
Very effective. Stainless steel? Is it plastic? Oh, yeah. Yep. But a bigger version. Yeah. Oh, okay.
The next step is to drill the hole, usually 1.5 millimeters in diameter. This machine takes approximately 1 second per scallop. Here is a view of a hole drilled into a sea scallop. The location is inside the byssal groove of the lower shell, and this prevents the pin from restricting movement or causing damage to the tissue. Eventually the pin will be overgrown right into the shell. Next, the group saw 2 machines for putting ear pins into the grow outlines. The first machine is the older of the 2, and pins were inserted manually, whereas the second machine is fully automated.
Set how far apart you want the pins to go in, and then you have this spool of pins, and it just sticks to the machine. Check it out, the rope runs out.
Of course, once pins are set into the lines, they need to be removed before the line can be reused. And there is a machine for this step too. Although ear hanging is a heavily automated process, it still appeared that putting the scallops onto the pins was a manual process. As you may have heard the translator say, the pins are put in from the lower or white side, again, to prevent tissue damage from the barb on the plastic pin. Here is an example done in Maine, with the pin fitting into the hole drilled into the Bissell groove. The barb of the pin stays outside the top shell, away from the mantle tissue. Maintenance on the water consisted chiefly of biofouling control, and machinery performed this task as well, in particular limiting damage from soft-bodied fouling organisms such as tunicates. Harvest is complete. The scallops go through another grater, this one a large drum type. There appear to be 3 grades and very high capacity. The last machine used to prepare scallops for market is a final cleaner, this time for hard-bodied fouling such as barnacles. The process looks fairly harsh, but resulted in a clean shell. This is Dana Morse from Maine Sea Grant and University of Maine Cooperative Extension. Thanks for watching.